projects. In this video, we are going to explain about the project title, a novel implementation of robust CT scan based brain diagnosis process using CNN technique. Before diving into the execution, let me give you an overview of the project. Brain tumors are abnormal growths of tissue that can develop inside the brain or the central spinal canal. They vary in size, location, and how fast they grow. When someone has a brain tumor, it can cause different kinds of problems depending on where it is. For example, it might make it hard for them to remember things, speak properly, or even some may be paralyzed. On top of that, brain tumors can also affect a person's emotions, making them feel anxious or depressed. In severe cases, these problems can be really serious, making it difficult for someone to do everyday things like walking or talking. Traditional brain tumor detection methods encompass CT and MRI, imaging, clinical assessment, biopsy, and angiography, offering crucial diagnostic insights for treatment planning. Yet, these methods may lack sensitivity and specificity, underscoring the necessity for ongoing exploration of advanced diagnostic modalities. The proposed system integrates individual filtering techniques, Wiener, Gaussian, median, and adaptive median to pre-process CT scan images before inputting them into a convolutional neural network CNN for accurate diagnosis of brain abnormalities such as tumors or hemorrhages. In this project, we have integrated Flask for building the web application to deploy our project. As an extension, we have used Flask, which provides a user-friendly web interface for this project, handling user authentication and image uploads, enhancing accessibility and usability. To implement this project, we need software and hardware requirements. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements of the project are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Algorithms used. These are the algorithms built in the project for detecting brain tumor. And here, CNN is the proposed model. So let me explain you what CNN is. The CNN in this project analyzes CT scan images, extracting relevant features to classify brain abnormalities. Through training on labeled data, it learns to differentiate between normal and abnormal brain images, facilitating automated diagnosis. Now let us execute this project. To execute this project, first we need to open the code folder, which contains the project source code files. So here, this is the dataset folder. In this dataset folder, we are again having two folders named as No and Yes. In the No folder, we have these scans which do not contain the brain tumor. And in the Yes folder, we have these scans which contain the brain tumor. So this data set will be used to train the models. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is the test cases folder, in which we have the test cases which we will use during the execution. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is the model folder, which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are new users, we need to register first. So click on sign up link here. So here we need to enter all these details to register. But I have already registered, so click on sign in button. So here we need to enter the username and the password, which are static, and then click on submit. We have logged in successfully and we are redirected to the prediction page. So here we need to upload the brain scans, which should be less than 500 KB in size. And after uploading the images, the application will detect whether brain tumor is detected or not. So click on choose file to upload the images. So I'm selecting the first image from the test cases. Now click on upload button. So here, this is the uploaded image, and here we can see the outcome, that is, you don't have tumor based on the input image. So here the person is not having the brain tumor. Now let us upload some more images. Click on try again. Now click on choose file. So I'm selecting this image. Now click on upload. So this is the uploaded image, and here we can see segmented image based on threshold. So this is the segmented image based on the threshold. And here we even have the segmented image based on morphology. And here this is the final image with contrast. And here we can see the outcome. You have a tumor based on the input image. So here this patient is having the brain tumor. And here we can see the segmented image based on morphology along with the segmented image based on threshold. Now let us upload some more images. Click on try again. Again from the test cases, I'm selecting this image. Now click on upload button. So here this is the uploaded image. And here we can see the outcome. You don't have tumor based on the input image. Now let us upload some more images. I'm selecting this image. Now click on upload. So this is the uploaded image, and here we can see we have the segmented image based on threshold. This is the segmented image, and here this is the segmented image based on morphology. And here this is the final image with contours. So here we can see the contours. And the outcome is you have a tumor based on the input image. So here this patient is having the brain tumor. Let us upload some more images. Click on try again. Click on choose file. Let us upload the images from the data set directly from the no folder. I'm selecting this image. Now click on upload. This is the uploaded image, and here we can see the outcome. You don't have tumor based on the input image. So here this person is not having the brain tumor.
Now let us upload one more image. Click on try again. Click on choose file. Let us upload the image from the yes folder. I'm selecting the second image. Now click on upload button. So here this is the uploaded image, and here we can see this is the segmented image based on threshold. And here this is the segmented image based on morphology. And here this is the final image with contours. And here we have the outcome. You have a tumor based on the input image. So here this patient is having the tumor, brain tumor. So in this way, just by uploading these scans, we can predict whether the person is having the brain tumor or not. Now click on logout link here. The conclusion underscores the CNN's effectiveness in accurately diagnosing brain abnormalities from the scan images, highlighting its potential impact on enhancing medical diagnosis and patient care.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.